So we're going to be practicing, again, solving equations, multi-step equations, but we're going to look at, for this section, special cases. Special cases are simply, there's three types of special cases when we're talking about multi-step equations. One, when you find one solution. Two, when you find no solutions. And three, infinite amount of solutions. I'm going to show you beginning when we find one solution, and that's the one that you usually come across the most while you're working these problems out. So let's start with this one, and let's see, and this is a one solution one. So we begin looking inside the parentheses, right? And these are not like terms, so we can't add anything inside the parentheses, and we want to get the x alone. So we're trying to solve for x, right? Okay, so we're going to have to break apart that x in the parentheses to be able to isolate it and figure out what the answer is. So we are going to have to use the distributive property, and we're going to get negative 3 times 4x plus negative 3 times 3 plus 4 times 6x plus 4 times 1 equals 43. Okay, so we basically distributed everything out. Now, we have to multiply each thing together. Negative 12x plus negative 9 plus 24x plus 4 equals 43. All right, now let's put our like terms together. What are our like terms? Well, we have an x with no power and an x with no power. So we're going to call this negative 12x plus 24x. And then we have, I'll do this one in green, a number with a number, negative 9 plus 4. Okay. So let's do the blue first, and we'll finish writing this. Equals 43. All right. So when we do this, we get negative 12x plus 24. I owe $12. I have 24. If I use my $24 to pay my debt, I'm left with $12, positive $12. And now I owe 9. I have $4. I use my $4 to pay my debt. If I have to use everything, but I still have a $5 debt, minus 5, right? Equals 43. Okay, so we have 12x minus 5 equals 43. Now let me put this together. 12x minus 5 equals 43. Now we just have a two-step equation going. We have to look at the x, whatever is plus or minus to the x, we add it on both sides. And we get 12x equals 48. We divide both sides by 12, and we get 1 times x equals 4. By the identity, multiplication identity, x is equal to 4. And there's our answer, one solution. When you have the variable that you're looking for equal to a number, okay, and we're talking about equations, which has only everything to the power of 1, it has one solution. That is, most of the time, that's what the answer is. Now, we're going to go over when it's not x equals. Certain things happen. So let's go through that. I'll pause this for a second, and let's change this. Okay, so this is one of our special cases. Let's take a look at this example now. So we have a variable here, no parentheses, but I cannot subtract 24a minus 22. They're not like terms, so I'm going to leave that alone. I have a parentheses here. I look inside, 1 minus 6a, right? I can't subtract those two because they're not like terms. So we're going to solve for a, right? Okay, so we're going to try and get the a alone. This, I'm just going to write it. 24a minus 22 equals, now, negative 4 times 1, because we got to break that a apart to get them to go together. And plus negative 4 times negative 6a. Okay, it's important to do that. So here's what it looks like. 24a minus 22 equals negative 4 times 1, negative 4. And it's negative 4 times negative 6. So when you're multiplying two negatives, you actually get a positive 24a. Okay, so far so good. Take a look at that. Take a moment to take it in. If you want, pause the video. All right, so now we're going to start again. Okay, now that we have simplified it quite a bit, we want the a's on one side and the numbers on the other. So, well, pick a side. They have the same number, they have the same coefficient, so I'm just going to move it to the left because that's the way we read from left to right. So I'm going to put negative 24a, negative 24a. Notice that I put it underneath the variable that it matches, and I don't put it under anything because when you add or subtract, you just do it once to each side. 24a minus 24a is 0 minus 22 equals negative 4 plus 0. Interesting. So now I get negative 22 equals negative 4 because that's the identity for addition. Now, is that a true statement? First of all, what do we notice? The variable canceled. That's a special case. The variable canceled. A. It got canceled. Right here. It got canceled. And what was left is not true. Not true. Now, it doesn't mean that, oh no, we did something wrong, we have to do it again. I mean, there are times you may make a mistake, but in this case, we didn't. It means if this is not true, this is not equal to that. That's what it means. Negative 22 does not equal negative 4. It just means there is no solution. Nothing works. Nothing works in there. There's no number that you can substitute a for. A, 2 and 2 that will give you equals. There's no number. There's no solution. And that's okay. That happens sometimes. Sometimes this is why it's called a special case. There's no solution. By the same token, so what we've seen in this video is one solution was the first example. Now no solution, right? I'll pause for a second. And the next one we're going to see is infinite number of solutions. Let's see how that works out. For no solution, it was negative 22, not equal to negative 4. It gave you a false statement. All right? So let's see what happens when it's infinite solutions, because that's the last special case for solving. We are going to solve for x. Solving for x. Let's do that. Okay. I can't add x plus 2. They're not like terms. I can't add x plus 1. They're not like terms. I can't add x plus 5. And that plus 4, when we have that parentheses and that minus 9, we can't do anything because they're all tied up to the parentheses. So we have to use the distributive property. 7 times x. I'm going to go ahead and write 7x. 7 times positive 2, positive 14, plus 4 equals 2 times x, 2x, plus 2 times 1, 2. 5 times x, 5x, plus 5 times 5, 25, minus 9. We got rid of all the parentheses. Now, let's take a look at our like terms. I have another x here? No. So I'm just going to write 7x. Now, I have 14 and 4. They're numbers. I can add them up. That's going to give me 14 plus 4 more will give me 18. Equals. Now, let's look at my like terms here. I have, use a different color for the x's. 2x. Do I have another x? You bet. Right there. And they're to the 1 power, so they're like terms. Do I have any other x's here? No. 2x's plus 5x's. Let me write them next to each other. 2x plus 5x. Okay. And now let's do orange. Okay. I have 2, I have another number, and I have another number. I'm going to write them all next to each other. Plus 2 plus 25 minus 9. Okay, so we can start to see how things go together. 7x plus 18. Now, here, This is 2 plus 5, right? 2 plus 5, x. That's what this means. If I have 2 x's and I have 5 x's, I have 7 x's. 2 plus 5, x, 7x. Now, plus 2 plus 25 is 27. Take away 9 is 18. Now look at what's going on here. I have the exact same thing on both sides. Let's try to get the x alone. I just want you to see how it looks. I'm going to move it to the left. Minus 7x minus 7x. Because it's positive, I'm going to subtract 7x from both sides. That gives me 0 plus 18 equals 0 plus 18. And using the identity of addition, 0 plus 18 is 18. 0 plus 18 is 18. Is 18 equal to 18? Yes. This is a true statement. So that means if your x's cancel, so when x's cancel, 1, your x's cancel, or your variable cancels. 2, the statement is true. This is true. 18 is equal to 18. It means infinite answers. Any number that we put in for x, 5, 16, if you put it in all the x's, you're going to get a true statement. Any number works. It's not like x equals 1, or like our first example, which was x was equal to, let's see, what was that first example? X was equal to 4. No. Any number that we put in for x, as long as we're consistent, if we pick 2 or negative 2, we do that for every x, it's going to give us a true statement. It's going to give me the same number on both sides of the equal sign. So this is infinite solutions. You're done. So just remember, if your variable cancels out, it's going to be one of two choices, either infinite or no solution. Infinite if you get the same number on both sides. No solution if you get two different numbers and it's a false statement. All right. I hope that helps, and I wish you good luck on your work. Remember to take your time when you're solving these things, and be careful with those negatives. They're tricky. Good luck.